After studying this module, you shall be able to learn about various techniques used to analyze evidence recovered from crime scene. Now let us start with a brief introduction. During the crime scene investigation, an investigating officer encounters with multiple different type of evidences. The type of evidence recovered depends on the type of crime scene. The evidence thus needs to analyze through various instrumental techniques depending on the type of evidence recovered from the crime scene. There are many techniques which helps in analysis of evidence. Various methods are used for analysis purposes. Now let us have a brief overview over the techniques. The following is a brief description of few important techniques used to gather potential information from the evidence and its application. Number 1. Polygraph or lie detector. The polygraph is used for the purpose of lie detection. John Augustus Larson was the one who invented polygraph in 1921. A polygraph measures and records several physiological indices such as blood pressure, pulse, respiration and skin conductivity, while the subject is asked and answers a series of questions. The analysis of polygram produced from polygraph is based on the belief that deceptive answers will produce physiological responses that can be differentiated from those associated with non-deceptive answers. Then comes brain fingerprinting. Brain fingerprinting was invented by Lawrence Farwell. It is a technique that uses electroencephalography, also known as EEG, so as conclude if any particular information is stored in the brain of an individual by measuring electrical brain waves and further recording the response obtained from P300 waves released from brains, that is also known as murmur. Memory and encoding related multi-facets electroencephalographic response in response to words, phrases or pictures which are shown on a computer screen. Now next is narco analysis. The term narco analysis was coined by Horsley. However, this technique first reached the mainstream in the year 1922 when Robert House, a Texas obstetrician, used the drug scopolamine on 2 prisoners. In the narco analysis, the hypnotic sedatives, preferably sodium pentothal, is administered intravenously into the subject. The dose which is to be administered in the subject's body is dependent on the age, sex, health, physical condition, tolerance and idiosyncrasy of the subject. The rate of administration of the drug is so adjusted such that the individual undergoing narco analysis is driven into state of hypnotic trance, thereby resulting in lack of inhibition. Although not impossible, but it becomes difficult in this state for the subject to lie or manipulate the answers. The subject is then interrogated by the psychiatrist, forensic psychologist in conjugation with investigating agencies. The revelation made during this stage are recorded both in video and audio cassettes, followed by preparation of the report about revelations, which will be accompanied by the audio-video recordings. The personal consent of the subject along with court order is required for the conduction of this test. Next is microscopes. There are limitless application of microscopy in the field of forensic sciences. The microscope is used to form an enlarged image of a small object. After enlargement of the image, the next concern is resolution. For many items such as ink lines, blood stains or bullets, no treatment is required. For examination of such kind of evidences, the evidence must be studied directly under the appropriate microscope without any sample preparation. Based on the investigation required, different types of microscopes are available and used for examination. The various microscopes are named as stereo microscope, compound microscope, polarizing microscope, comparison and scanning electron microscope. Now, scanning electron microscope provides superior result and hence is used in many applications areas such as gunshot residue analysis, investigation of gemstones and jewelries, firearms identification with the help of bullet marking comparison, filament bulb investigations at traffic accidents, handwriting and print examination or forgery, examination of paint particles and fibers, counterfeit banknotes, examination of non-conducting materials, trace comparisons, and lastly high resolution surface imaging. Now let us see what is Abbe refractometer. Abbe refractometer is used to measure the refractive index of the given organic liquid. It is a bench-top device for the high precision measurement of an index of refraction. Then comes voice spectrograph. It can be defined as both auditory and spectrographic evaluation of one or more known voices of an unknown voice for identification or elimination. The most important parameter used in this determination of voice identification is the size of vocal cavities, for example, nasal, throat and oral cavity, and also the length, shape and tension of the individual's vocal cords located in the larynx. The second parameter is the manner by which the articulator or muscles of speech are manipulated during speech. The samples of voice recovered from the scene can provide valuable evidence after analysis from their voice spectrograph. Let us now discuss about Docubox Dragon. Docubox Dragon allows comprehensive and systematic examination of documents in field application. Extensive examination techniques with effective management and operative accessibilities achieve the growing needs for a fast and well-organized investigation of travel documents, currencies, and security published documents in the lab. The different lighting conditions provide easy examination of document with differentiation of ink in a convenient manner. Now let us see video spectral comparator. Video spectral comparator comprises of two components. Number one, a desktop computer that runs on software and an imaging device that includes a color charged coupled device, video camera, a black and white CCD video camera, excitation barrier filters and various radiant energy sources. The instrument is equipped with the specialized lighting tools for examination of documents. The visible infrared luminescence, ultraviolet transmitted, coaxial and oblique lighting conditions may be used alone or in combination. It permits the analysis and comparison of inks, revealing alterations on a document as well as whole question document without consuming much time. Now, printing examination using video spectral comparator. The VSC 5000 can be used to examine printed documents. The examination under different lighting conditions can show that a document has been altered. Even without a source printer, it may be possible to opine that two documents were both produced using the same printer or not. Counterfeit pharmaceuticals, cigarettes, security documents, etc. can be examined by looking at the packaging. By comparison with genuine packaging, it is possible to link counterfeit packaging together by printing methods and defects. If the printers which have been used to produce the packaging are found, then it is possible to link the counterfeits to the printers. Now let us discuss UV-Vis Spectrophotometer. Analysis of question documents involving forged bank checks, altered documents, tickets and counterfeit bank notes frequently include the ink examination to establish the source of an ink used to print the fake document. Besides a large number of ink formulations, UV fluorescing additives can be informative from the forensic point of view. The different colored inks such as black and blue ink may look same, but there may be some important differences in their chemical formulations. The basic principle of UV visible absorption is that the molecules having a p electrons, n electrons, that is non-bonding electrons, will absorb energy in the form of UV or visible light so as to stimulate electrons to a higher anti-bonding molecular orbital. Then comes atomic absorption spectroscopy. It is a spectral analysis process for the measurable purpose of chemical elements using the absorption of optical radiation by free atoms in the gaseous state. Let us discuss now Raman spectroscopy. It is a spectroscopic method based on inelastic scattering of one color light, generally through a laser source. It basically means that the occurrence of photons in one color light deviates during interaction with the sample. Raman effect is defined as the frequency range where the re-emitted photons are shifted up and down in comparison with the actual monochromatic frequency. The shift in frequency gives information about vibrational, rotational and other low frequency transitions in molecules. Raman spectroscopy can be used to study solid, liquid and gaseous samples. The technique is used to analyze different evidences such as drugs, inks, etc. Now let us see Fourier transform infrared spectroscopy. FTIR spectrometry deals with the infrared region of the electromagnetic spectrum, that is light with a longer wavelength and inferior frequency than visible light. The IR portion of the electromagnetic spectrum is typically separated into three regions: the near IR, mid IR and far infrared. It is very useful for qualitative analysis of compounds. IR spectrometry is based upon the ability of certain substances to absorb infrared radiation by interaction of an IR beam with the molecular bond of the sample. Absorption occurs when the molecular bond has a vibrational frequency equal to the IR beam. The technique allows analysis of all state of matter, drugs, chemicals, inks, toners, etc. can be analyzed using this technique, various biological and chemical evidences. Now let us discuss chromatography. Chromatography is the collective term for a set of laboratory techniques used for separation of mixtures. The combination is mixed in a liquid known as the mobile phase, which transports it by an arrangement carrying substances known as stationary phase. The several components of the mixture travels at various speeds and makes them to detach. The partition, coefficient is dependent on the difference between the mobile and the stationary phase. Now, let us have a look on thin layer chromatography. Thin layer chromatography is broadly engaged lab method. It involves a stationary phase of a thin layer of adsorbent on a flat inert substrate. It runs swiftly while parting and the choice between dissimilar adsorbents to achieve better resolution, and also for quantification purposes, high performance TLC can be used. Now let us discuss high performance thin layer chromatography. HPTLC, also better known as high performance thin layer chromatography, is the improved method of thin layer chromatography. Various enhancements are possible to the general or basic method of TLC so that the different steps can be automated to increase the resolution achieved and to allow more accurate quantitative measurements. High performance liquid chromatography. High performance liquid chromatography is a technique used to distinct, identify and quantify each component into a mixture. It depends on pumps to pass a pressed liquid solvent having the sample combination by a column occupied with a solid adsorbent material. Now let us discuss gas chromatography-mass spectrometer. Gas chromatography-mass spectrometer is a technique for the analysis and quantitation of organic, volatile and semi-volatile compounds. Gas chromatography is used to distinct combinations into separate components by a temperature controlled capillary column. Next is inductively coupled plasma mass spectroscopy. Inductively coupled plasma mass spectrometry is the fastest rising trace component technique. Since its commercialization in 1983, the technique has covered a wide range of application areas including forensic, environmental, geochemical, semiconductor, clinical, nuclear, chemical, metallurgical and many other scientific disciplines. The technique allows rapid sequential multi-element determinations of nearly 70% of the elements in their periodic table with atomic mass ranges 7 to 250 at the ultra trace level. This encompasses lithium to uranium. ICP-MS is the synergistic combination of two well-established techniques, namely inductively coupled plasma and mass spectrometry. The several elements of inkjet inks has trace impurities coming from several sources, either naturally present or due to adulteration. It is impracticable to remove them altogether. Among the impurities or contaminants, there are several metals that are present in the inks at trace levels. Depending on the place of manufacture, source of raw materials, formulating technology and contamination, the trace metal profile would be a very good criterion on which different inks could be characterized. Nonetheless, the inorganic elemental constituents within gel inks can come from a wide range of sources. The chief provider to the fundamental components of ink is the colorant, which comprise the adding of any number of inorganic pigments or organic pigments or a combination of both. Besides the vehicle of the inject inks, the additives are another main basis for the fundamental arrangement like pH regulating agents. The inorganic trace element constituents found in inject inks can virtually come from any of the manufacturing process and the stated raw material. The technique can also be used to analyze various other evidences such as water. Differential thermal analysis. It consists of measuring changes in heat content as function of difference of temperature between the sample under investigation and a thermally inert reference compound as the two materials are heated at elevated temperature or cooled to subnormal temperatures at predetermined rates. In this manner, enthalpy changes such as melting, vaporization, crystallographic phase transition or chemical changes are detected from the endo to exothermic bands and peaks that appear on the thermograms. The corresponding change in weight is determined by thermogravimetric analysis. Complete thermoanalysis data are obtained only by utilizing both methods of analysis. The information obtained, coupled with X-ray diffraction, optical and chemical analysis of the residues and any involved gases, provides a quantitative estimation of solid state reactions. Next is electrophoresis. Electrophoresis is the motion of dispersed particles relative to a fluid under the influence of a spatial uniform electric field. Electrophoresis of positively charged particles, which are cations, is known as cataphoresis, and electrophoresis of negatively charged particles, which are anions, is called anaphoresis. Electrophoresis is a technique used in laboratories in order to separate macromolecules based on size. This technique is used to analyze biological evidences. Now, dear students, let us summarize this chapter. So, in this chapter, we have learned that the polygraph is used for the purpose of lie detection and was invented by John Augustus Larson in 1921. Secondly, in this chapter, we have learned that polygraph measures and records physiological indices such as blood pressure, pulse, respiration, and skin conductivity, while the subject is asked and answer a series of questions. Thirdly, in this chapter, we have learned that brain fingerprinting is a technique that uses EEG to determine whether specific information is stored in a subject's brain by measuring electrical brain waves and recording a brain response known as P-300 murmur. Fourthly, we have come to know that brain fingerprinting was invented by Lawrence Farwell. Fifth, we have learned that murmur stands for memory and encoding related multifacets electroencephalography response. Then we have come to know that in the narco analysis, the hypnotic sedative is administered intravenously into the subject. And after learning this chapter, we have also learned that the dose of hypnotic sedative which is administered in the narco analysis is dependent on age, sex, health, physical condition, tolerance and idiosyncrasy of the subject. Then we have come to know that various types of microscope such as stereo microscope, compound microscope, polarizing microscope, comparison, scanning electron microscope is used for forensic analysis of samples. And then we have also learned that a scanning electron microscopy is used in many application areas such as gunshot residue analysis, investigation of gemstones and jewelries, firearms identifications, filament bulb investigations at traffic accidents, handwriting and print examination forgery, examination of paint particle and fibers, counterfeit banknotes, examination of non-conducting materials, trace comparison, high resolution of surface imaging. Then we have learned that Abbe refractometer is used to measure the refractive index of the given organic liquid. We have also learned from this chapter that Docubox Dragon and Video Spectral Comparator allows comprehensive and systematic examination of documents in lightning conditions, provides easy examination of document with differentiation of ink in a convenient manner. Then we have also learned that the technique allows analysis of all state of matter, drug, chemicals, inks, toners, etc. can be analyzed. Using this technique, various biological and chemical evidences are also analyzed. Inductively coupled plasma mass spectrometry is a technique for the detection of trace. ICP-MS allows multi-element determination of the element at the ultra trace level. NCASE is used to recover deleted data from storage devices such as compact disk, hard disk, floppy disk, etc. And we have also learned that electrophoresis is defined as the process wherein the dispersed particles are in motion relative to the specific fluid under the influence of an electric field which is uniform and used to analyze biological evidences. We have also come to know that chromatography is a technique used for separation of the mixtures. And lastly, my dear students, from this chapter, we have learned that the various chromatographic techniques are used to analyze evidence recovered from the crime scene are thin layer chromatography, high performance thin layer chromatography, high performance liquid chromatography, gas chromatography, mass spectrometry, etc.